Welcome to Ingenious Physics channel. Today we will discuss about velocity time graph. So let's start. So in the first case we will draw a graph for uniform velocity. So for uniform velocity graph we will draw a VT graph first. So the x-axis always represent the time and y-axis represent velocity. Okay. In uniform velocity, as we know that velocity remains always same. So we have considered a velocity that 40 meter per second is the velocity of a particular object. So as the time passes, that means 1 second, 2 second, 3 second, 4 second, 5 second, what we get? We get that in time is equals 1 second, the velocity of the object is 40 meter per second. When time is equals 2 second, again the velocity is 40 meter per second. When time is 3 second, then also the velocity is 40 second. When time is equals 4 second, then also 40 meter per second. When time is equals 5 second, then also 40 meter per second. Means time keeps on changing, but the value of velocity remains same. You have to the time keeps on changing, but the value of velocity is always same. So this is the graph. The straight line which is parallel to the time axis represents the uniform velocity. In uniform velocity, you have to clear the concept that initial velocity and final velocity will be always same. And as we know that acceleration is equals v minus u upon t. So here v and u both are same, then definitely acceleration must be 0 meter per second square. Okay, so always remember a straight line parallel to time axis gives the uniform velocity. Okay, coming to the next graph, in point number 2 we will draw a VT graph first, then we will analyze that what we are getting here. Okay, so this axis represents time and this represents velocity as we know that. Okay, suppose that now we draw a graph like this. So when time is equals 1, 2, 3, 4, 5 and 6 seconds, so we get a corresponding velocities, something like this. In 1 second we have some velocity, in 2 seconds we have some velocities, in 3 seconds we have other velocities, in 4 seconds we have other value of velocities, in 5 seconds we have other value of velocities, in 6 seconds we have other value of velocity. So what we get, when the time keeps on increasing, the velocity is also increasing. And since we have to observe here that suppose that we are just taking some values here, so this represents 5 meter per second, 10, 15 meter per second, 20 meter per second, 25 meter per second, 30 meter per second. Okay, when we discuss about the time duration 2 to 3 seconds, so the time interval is of 1 second, and in this time interval what we get, the difference is 5. Always remember the difference will be 5 meter per second. We will consider other part like this 4 to 5 seconds, so the time difference is again 1 second. Now we will observe that does the velocity difference is same as 5 meter per second or any other value. If the velocity will be same as 5 meter per second, then this graph shows uniform acceleration. Okay, so now in 4 to 5 seconds what we get, there is a gapping of 5 meter per second. Okay, so always remember that whenever a graph is plotted just like a straight line and the straight line is inclined to the time axis, then what it gives uniform acceleration. Uniform acceleration, always remember this, my dear. So uniform acceleration is positive here, acceleration is positive, always remember. So acceleration positive, that means the final velocity must be greater than initial velocity. So you can analyze this by the formula also, something like this. If A is equals v minus u upon t, if v is greater than u, then definitely this term is going to be positive. Okay, so this is the graph for the uniform acceleration. Coming to the next point, that is third point, uniform retardation. Uniform retardation. As we know that whenever there is a retardation, that means acceleration is negative. So when acceleration will be negative, we can analyze from this formula. Whenever v is less than u, then the value of acceleration will always be negative. So in this case, the final velocity is less than initial velocity. Okay, so we will draw a graph for this. This is a time axis and this is velocity. So definitely the graph for this will be a straight line but making an angle more than 90 degree with the time axis. So this graph represents retardation, uniform retardation. Okay, so we have considered three cases. In first cases, what we have considered, whenever the value of u and v is same, then that represents uniform motion. Whenever final velocity increases with respect to initial velocity, then definitely there must be positive acceleration, and whenever the final velocity decreases, then the acceleration is always negative. That is known as retardation. You have to keep in mind these three graphs. Okay, these are very important for your examination.